Hi everyone, today we are going to have tutorial number 7. So today we are going to discuss the task of summarization using Hugging Face. So let's get started. So as you can see, I have connected the GPU runtime in my Colab, and this notebook again will be shared on the course website. These are the few packages that we need, data sets, evaluate, transformers, RuScore and NLTK. Let's install them. So you can install packages in Colab with a bang symbol in front. As you can see, these has been installed. Let's see what transformers version we have. So as you can see, this is 4.47. So when we are pushing model, so we can push models and our datasets onto Hugging Face. So when we are doing that, we need to log in with our Hugging Face access token, that you can access the models, your models and datasets on Hugging Face Hub. So you can do this via login, and you can get the access tokens in the Hugging Face settings when you log in into Hugging Face. Now let's run some utils. So today we will be fine tuning a model on summarization task. So in this notebook we will see how to fine tune one of the transformer model for summarization task. We will use the XSUM dataset or extreme summarization, which contains BBC articles accompanied with single sentence summaries. So for a glance, this is the XSUM dataset paper. I encourage you to go through the paper to get into the nitty-gritty details of the dataset. So as you can see, this is the input, okay, the document, and we get a one-line summary. So we feed this to the model, and the model should give us a one-line summary of the input. This is the paper. So we will see how to easily load the dataset for this task using datasets library. Again, that library is by Hugging Face, and how to fine tune the model on it using the trainer API by Hugging Face. So we will be using a T5 model. So T5 model is basically comes from Google research. It is exploring the limits of transfer learning with a unified text to text transformer. This so this is what the T5 model, a diagram of our text to text framework. So every task in the T5 model has been given by a NLP task, by a text task. So let's say the translation task. So translate English to German. This is good. The model outputs this is good. So we prefix the task in front of our input with some prefix, with some, let's say it's a translation sentence. Now it is STSB sentence, so syntax classification task. Then summarize. So what we are going, so we append summarize in front of the sentence, and the model understands that it is a summarization task. So the model just give outputs a summary of the text given. So text to text models, the transformer model summary is a transformer based model developed by Google research that frames all NLP tasks as a text to text problem. This means that both the input and the output are treated as plain text strings, making it highly flexible and generalizable across various NLP tasks such as translation, summarization, summarization, question answering, and text classification. So the key features of T5 model is basically unified framework for all NLP tasks. All NLP tasks is basically casted into a text to text problem, and pertaining on C4, the large scale dataset from Common Crawl, and it is an encoder decoder architecture. So we will be using the T5 small model, which is from Hugging Face. So this is the T5 small model page on Hugging Face. You can go through. There are some details about the Hugging Face, like developed by model type, the languages, and so on and so forth. And also there is a multilingual version of the T5 model, which is multilingual T5 or MT5, which supports around I guess 110 languages or 100 languages. Need to check the exact number. So loading the dataset. So we will use the datasets library to download the data and get the metric we need for evaluation. So the dataset we can use the from datasets, load dataset function, and for evaluation we will use the evaluate package again from Hugging Face, and we will use the load function to load the metric that we need. For our case, it's a roux metric. So let's see, the model is running, the cell is running. So it is so we need to pass the access token. Yes, do you wish to run custom code? So yes, we will run custom code, and this is generating the, it has downloaded the data, it is generating the train split, train dev and test split on the fly. So this all comes out of the box when you use the load dataset function from datasets library of Hugging Face. It's a pretty good and pretty fast library. That's backend is written in Rust, and these are the Python APIs that has been provided by the library. It has generated the training split. Now it is generating the validation split from the dataset. It is a pretty big dataset, as you can see. The tar size is 255 MB. So when you uncompress it, it's pretty big of a dataset. Now it is generating the test split. Now it has generated the test split, and it has, the metric has also been loaded. Let's see what our dataset. So we have initialized our dataset as raw datasets because it is not tokenized, so it is raw. So let's see how our datasets look like. So the dataset object is itself a dataset dict, which contains one key for training, validation, and test set. So as you can see, the train, it's a dataset with features, document, summary, and ID. Number of rows is around 2 lakhs. The validation is around 11,332, and test is 11,334. Now to access an actual element, you need to select the split first. So split, as you can see, we need to select the split first, then give an index, just like Python list access. So as you can see, for the 0th item we get a document, and we get a summary and an ID. So if we pass in another index, you will see we get a different document. Now to get a sense of what data looks like, the following function will show some examples picked randomly from the dataset. This is just a small helper function to show us the randomly 5 examples from the dataset and how it looks like. So as you can see, this and this, the first column is the data, the first column is the document, and the second column is the summary, and the last column is the ID. Now what is a metric? What is our metric? Now if we check metric, the evaluation module is the signature that we are getting from Hugging Face. I think if so that is you are getting from Hugging Face, and Hugging Face has good examples also. So small examples, how can you use it, and so on and so forth. And more details, you can go and check the documentation. It's the documentation of Hugging Face. It's pretty good, very well documented, very all sorts of examples are there. Go and have a look around it. Now we will be using a RU metric. So what is a RU metric? RU is basically recall oriented understanding for gisting evaluation, is a set of metrics for evaluating automatic text summarization and machine translation. The most commonly variants are RUN, RUL, RUW and RUS. Now these are few mathematical formulation for each. RUN, recall, precision, F1, and this G is basically set of all n-grams, count, match. G is the number of n-grams in the system summary that also appear in the reference summary. Ref is the n-grams in the reference summary. Count Cis is the total number of n-grams in the system generated summary, and beta is the weighing parameter for weighing parameter for making a harmonic mean between precision and recall, and so on and so forth. This is a rho n, then we have rho L, then rho W, rho S. So there is a summary of everything. So rho n is basically n-gram overlaps, unigram, bigram, etc. Rho L is the longest common subsequence. Rho W is weighted longest common subsequence, and rho S is skip bigram co-occurrence. So each matrix helps to evaluate different aspects of the summary quality, with rho 1 and rho 2 being most commonly used. So let's say we have this hello there and general Kenobi, and we have fake. So these are fake predictions, and then we have fake labels. So let us compute predictions equals to this. So this is the test, how we can test it. So as you can see, rho 1 is 1, rho 2 is 1, rho L is 1, and rho L sum is also 1, because these are predictions and labels are the same list. Now before we feed these texts to our model, we need to pre-process them. So this is done by the tokenizer, transformers tokenizer, which will tokenize the inputs, including converting them to converting the tokens to their corresponding IDs in the pre-trained vocabulary. We know what each model has a pre-trained vocabulary of itself, which is fixed, and put it in the format that model expects, and as well as generate other inputs that the model requires, like the attention mask, labels, and so on and so forth. To do this, we will instantiate our tokenizer with the auto tokenizer dot from pretrain method, so which will ensure that we get a tokenizer that corresponds to the model architecture we want to use. We download the vocabulary used when pre-training this specific checkpoint. So this vocabulary will be cached, and so it's not downloaded again next time when we run the cell. So this auto tokenizer is a function that is coming from the transformers library. So when we pass the model checkpoint, it goes and fetches the T5's tokenizer, and it gets that from the model. So by default, we call one of the fast tokenizers that is backed by Rust, again from the Hugging Face tokenizers library. So we have our tokenizer here, and let's call our tokenizer on hello. This is one sentence. So as you can see, this converts these sentence into tokens. So there is 1, 2, 3, 4, 5, including this bang symbol, but here we have 1, 2, 3, 4, 5, 6, 7. So that means this has been, the sentence has been tokenized and has been converted into IDs, and then we have the attention mask of each of the IDs. So depending on the model you selected, you will see different keys in the dictionary returned in the above cell. So if this is a T5 model, then if you use a BART model, and so on and so forth, you will see the tokenization is different due to the vocabulary and the tokenization method that they choose. So hello, this is one sentence, then we have another sentence. As we can see, we get two lists of lists, and similarly attention masks. To prepare the targets for model, we also need to tokenize using the text target parameter. So we not only need to tokenize the input, but we also need to tokenize the output. So for that, we pass in the text target parameter, so which tokenizes the output, and also while giving us the predictions, it detokenizes. We have to detokenize these input IDs for our target. Now if you are going to use one of the 5 T5 checkpoints, so T5 has various checkpoints, like if you go through the paper, this paper, you will get to know all of those. It's T5 small, T5 base, T5 large, T5 3 billion, and T5 11 billion. Now for the summarization task, as you have seen here, for the summarization task we put a summarize prefix in the front of each sentence of each input. So prefix is summarize. So let's run it. Now we will write the function that will pre-process our samples. Pre-process means tokenize our samples for providing it to the model. So we just feed them to the tokenizer with the argument truncation equal to true. So truncation equals to true helps in truncation of the sentences to the max input length or the max target length that we provide to the pre-process function. So as you can see, inputs is basically prefix plus doc for examples in the document. We provide in examples of the document. Document is the column that we are getting it from each of the samples, and model inputs is tokenizer inputs, max length and truncation equal to true. Like if the sentence exceeds this 1024, we will chunk it. And labels also set up the tokenizer for the targets, like text targets, examples of summary, and max length is max target length. So as the summary will be smaller than the input, so we will truncate the output to the max target length, and also truncation will be held true. So let's run the preprocess function. Now let's see the two examples and how this. So this is what the preprocess function does. Converts the raw data sets of first two samples 0 and 1 from the training into the IDs, and here are the attention mask, and similarly here are the labels. Now we will tokenize the whole data set. Now how can we do that? We can do that using the raw datasets.map function. So we will map. So this map function will apply this preprocess function on this raw datasets with batched equal to true. We will make it much faster. We will do this mapping of the preprocess function in a batch, let's say 8 or 16 or whatever this raw datasets. This map function feels like how much is available in the CPU. It will do it on the fly. So it is mapping that on the fly, and so it is mapping examples on the fly. It will take a bit of time. As you can see, there's a lots of examples, around 2 lakh examples is there. So let's see the data sets map Hugging Face. So this is the map. As you can see, the map function. Now this is the map function. So map function, this is the signature of the map function, as you can see. So this is in the datasets main classes package reference map function. This takes with indices with rank. These are the arguments that can be set. The batch size can also be set. It is default to 1000. You can increase or decrease it. You can also remove columns. You can load from cache file, use specific features to cache, and so on and so forth. Then so as you can see, dataset.map, it maps the dataset. There is a small example also given. As I have already told you, the Hugging Face documentation is pretty well written and easy to understand. So if you ever face any doubt during your coding your experiments, please go through the documentation. So let's go on. So now fine tune the model. So we have our tokenized data sets, we have and we have our model also. So after this finishes, we will pass. Now let's first instantiate our model. So now the data that our data will be ready, we can download the pre-trained model and fine tune it. So since our task is one of the sequence to sequence kind, we use the auto model for sec to sec class. So auto model for sec to sec class is so this is a sequence to sequence task, a text to text output. So we will require now auto model is what the Hugging Face API will take care of it, and will based on the checkpoint it will give us the model will be instantiated by the corresponding class. It is around halfway done. So from transformers we will import the auto model for sec2sec, data collator for sec2sec, sec2sec training arguments, and sec2sec trainer. Now what are each of these we will go through. Now to instantiate a sec2sec trainer, so we need to define three more things. The most important thing is sec2sec training arguments. So sec2sec training arguments is basically a class that contain all attributes to customize the training. Okay, so let's check the documentation. So let's say sec2sec trainer. Let's check here. Yeah. So this is the trainer API, the trainer class, that is API that is feature complete training with PyTorch, and you can run distributed training with multiple GPUs and so on and so forth. So for the trainer we have the sec2sec trainer and sec2sec training arguments. The sec2sec trainer the function basically looks like this. So the sec2sec trainer sets the training for the sequence to sequence task, specifically for a sequence to sequence task. And then we have the sec2sec training arguments. So sec2sec training arguments is the arguments that we need to pass to the sec2sec trainer API for the model. Like there, as you can see, there are 120 parameters. So like, do we need to train it, or we need to evaluate? Like, what is the evaluation strategy? How much gradient accumulation we can put, like eval accumulation, what is the learning rate, what is the weight decay, what is the Adam beta 1. So these are the parameters for the Adam W optimizer. How much max steps that we want to train, the learning rate scheduler, the learning rate scheduler quarks. So these are specifically for the learning rate scheduler. Then we have warm up steps and so on and so forth. What is this number of steps, number of update steps between two saves, checkpoint saves. What is the save total limit, like instead of saving every checkpoint, what is the total number of limits that we want to save. If we want to save in the format of safe tensors and so on and so forth. If we want our training to be in BF16 or FP16 or TF32 and so on and so forth. There are much. Please go through the documentation of the trainer API. I think yeah, it has been done. It will be done. Yeah, so the training, so this is the training split. So the training split has been mapped. So we are mapping the whole raw data sets which contain train, validation and test. So this is going to tokenize every split of the training. So we have mapped the training. Now the cell, this is training, the validation, and I think yeah, so this will tokenize the split also, the test split also. Yeah, so our data set is now, our data is ready. We would instantiate our model with the auto model for sec2sec. So it is, as you can see, it is downloading the model ceph tensors config and generation config. So it has downloaded the T5 small checkpoint from the Hugging Face hub. Now to instantiate, now we would instantiate the sec2sec trainer. The first thing, we need to instantiate the sec2sec training arguments which we would pass to the sec2sec trainer. So sec2sec training arguments. So this is the save path. The evaluation strategy we will be saving on each epoch. The learning rate is 2 to the power minus 5. So batch size, we set a batch size to 16. So this is training batch size. Evaluation batch size is the weight decay. Total limits, like we would set the total number of saves of the checkpoint to 3. Number of epochs is 1. Predict with generate is true. This is due to the fact that when the model with output, it will predict and generate the output at the same time. Now we have set the floating point 16 bit to true, and this is here. Report to is basically you can check your logs in TensorBoard or weights and biases, so you can link your Hugging Face to those services also. So we have set, so for now I have set this to none, so you don't want to report anywhere. Now here we said, now after we have instantiated this, we would need to collate. Now we set the evaluation to be done at the end of each epoch. Tweak the learning rate, use the batch size defined at the top of the cell, and customize the weight decay. Now since the sec2sec trainer will save the model regularly and our dataset is quite large, we tell it to make 3 saves maximum, so by this parameter. Lastly, we use predict with generate options to properly generate summaries and activate mixed precision training for a bit faster. So this is mixed precision training. Now we need to instantiate the data collator for sec2sec. So thus we need a special kind of data collator which will only pad the inputs to maximum length in the batch, and but also the labels. So we need to pad our data for the input, we need to pad it to 1024, and for labels we need to pad it to 128. So data collator for sec2sec does that. Now the last thing that to define for our sec2sec trainer is how to compute the metrics for our predictions. We need to define a function for this, so which will just use the metric as we loaded earlier and do a bit of pre-processing to decode the predictions. So as you have seen, we also did also tokenized the labels, so we need to detokenize them. So this function does that. It's a pretty simple function which does this. So it has been so here is the metric that we are calling. So predictions equals to decoded predictions and reference equals to decoded labels. So which we are we are batch decoding here, tokenized batch decode. We are decoding from the tokenized version to the raw text, and we are passing it here, and we are all and extract a few labels, so extract a few results. So we are extracting these and we are storing these in the dictionary. Now we need to pass all of this into the sec2sec trainer API. So what does sec2sec trainer API? So if you hover on top of this, you can also see it here, or if I think if you do so, as you can see, if you do this, you can get the signature in here also. What are the so as you can see, what are the arguments that the model take, and so on and so forth. So this is the args that it takes. Please go through the documentation or look at the signature here, there, right? So we get pass the model, and this args is basically the sequence to sequence training arguments. We have initialized this sequence to training arguments and put it in the args variable. So we are passing args here. We are putting the training data set. So this is the tokenized data sets of train. The eval data set is tokenized data sets of validation. Now we pass in the data collator, we pass in the tokenizer of the model, and we also pass in the function for the training, the metric calculation, we pass that in. So we run this. So as you can see, this has been run. Now we can fine tune our model by just calling the train function of the trainer method. Now if we click on this. So as you can see, the model has started training, and one epoch, since it's a very large data set, one epoch will take around 2 hours 39 minutes and so on. So I will stop it here. Now please run it in your leisure time at your home, and this is pretty free. This is free, so you can run it in your own time and check the inputs and check the outputs, predict with them, and check the scores. So here in this tutorial we have seen how to do the summarization task using Hugging Face and using the model using the T5 model. Please use some other models like BART and so on and so forth. You can also go ahead and check these large language models, Llama. It's pretty similar with same as our tutorial notebook, and this is the XSum dataset. You can also play around with other datasets. You can find many summarization datasets on Hugging Face also. Yeah, for today this much. Thank you.